All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We, of course, are going to pick up where we left off on the last stream. So, before we jump into that, I just want to take a quick second and thank the supporters of the channel, starting with our elite partner, who is Javier Alazaran. I'd also like to thank the partners listed here, Furkan Tokan and Gerbolis Inc. Those are the highest tiers of subscription over on YouTube memberships and Patreon. I'd also like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me cover the costs of hosting this project, hosting the website, various licensing fees, things like that, expenses that come up. So thank you all very much for your support. I greatly appreciate it. And of course, I hope it goes without saying that I appreciate each and every one of you viewers, whether you're here catching us on the VOD after the fact, or whether you're joining us here live, either on the Twitch side or the YouTube side. We do have both up. We simulcast to both. And I do my best to keep an eye on the chat. This is an interactive stream, so feel free to jump in and ask questions if you have them, and I'll answer them to the best of my ability, or if you just want to say hi, that's cool too. All right, so what we are looking at here on the screen is just kind of a little diagram that I drew up to kind of summarize a little bit of the work that we've done thus far and kind of the direction that I'm going to be taking things going here in the future. So a little bit, some of this will probably look familiar to you if you've been following along with the series, and some of it may look new. And this is part of the sort of large reorg that we're doing, and I'm kind of feeling this out as we go through it, so that you guys can get an idea of my design and thought process and things like that, and how I approach these problems, because hopefully that's useful, right? So essentially what we have is, right now we have a scene, which is working just fine, and it has its own sort of, it has this node system with attachments. And we're going to essentially be replacing that, right? So a node is essentially just a thing that exists in the world, and then you can have attachments to it, which the attachments can be of various types, whether it be like a static mesh or a skybox or a point light, something like that, right? And for the most part, we're going to be changing just the way those things are named, just to make them a little bit more clear. But a little bit of the behavior and how they're going to act is going to change as well. So this is everything that you see here on the screen is essentially our new way of sort of doing things, or at least what we're going towards. So we have our scene, which consists of a hierarchy of these actors, right? These K actors that we kind of talked about before. And this is just a simple object that exists in the world, that can be spawned in the world, or it already exists in the world. And it has a transform, it has a couple of other properties like a name, a unique ID, things like that. But ultimately what it serves as is it serves as a sort of an actor component container, more or less. And we may have specialized actors down the road. I haven't really decided if we're going to do that yet or not. Probably we are going to be doing that, but for right now we're just kind of keeping things generic. So a K actor component, right, or an actor component if you want to think of it that way, is essentially something that modifies the actor in some way. So it can control how it's displayed, it can control how it sounds, it can control even how it behaves, right? You can add a component to it that maybe hooks into keyboard input that moves it around, for example. So that's certainly one way of hooking that up and making things configurable, right? So each of these component types. So we're going to have a bunch of different component types. The one that I'm using here as an example is a static mesh component. Each of those has their own individual system, and that individual system is responsible for maintaining its data and any operations that need to happen against it. So rather than following the sort of object-oriented approach where you would have all these sort of structs that are flying around and function pointers and things like that, the way that we're organizing this is the actor component essentially belongs to a system which is responsible for how it lays that stuff out in memory all on its own. And we can use that system to interact with a component via an ID. So we don't ever typically actually wind up having an actor component structure, as it were. That's all internal to the individual system. We simply, it's essentially a black box that we input data into and get data out of, and it's up to that individual system to manage its own memory and optimize things accordingly. So that the requirements for that obviously are going to vary depending on what the individual actor's requirements are, and thus the system will know how to go ahead and handle that. So that's that bit. And then actor components will typically have some sort of resource instance. And we haven't talked about resource instances yet. So before we get into what a resource instance is, to keep that term in your head for a second, we're going to talk about the sort of flow of events and how we wind up getting to this instance. So whenever we crank up a scene, whenever we say, hey, we're going to load a scene, what happens is it's going to iterate through all of its actor components within that scene. And essentially what we're going to do is when a K-actor component is loaded, right, meaning that its system has been reached out to say, hey, load this, right? In this case, a static mesh is what we're going to talk about. So we're going to talk about the static mesh system directly. So it'll say, hey, static mesh system, load this particular component. And so what that will do is it'll essentially execute specialized functions for loading up a static mesh. Thank you for the follow, by the way. And so let's see, we'll come back to that note. So essentially the way that this works is the static mesh system will be responsible for outputting data for a static mesh, right? So the first thing it does is it has to, depending on the system, of course, and the system requirements, it's probably going to reach out to the K-resource system, which we've already done. And that K-resource system is going to be responsible then for loading up an asset or assets, depending on the type of resource that we're loading, from disk. So in the case of a static mesh, that's going to be a single asset, right? And so the K-resource system is going to say, hey, I need to load this asset off of disk. And so it'll go ahead and perform a request to the K-asset system. Now that request is asynchronous, but what it does is it immediately returns a pointer to that asset. The asset may just not be loaded yet, so we can kind of keep tabs on that. And so ultimately, the asset is returned to the resource system where it's processed and prepared for use as a resource, asterisk, when loaded, right? So the resource system has the capability to watch for assets loading for each resource type. There's an internal handler for each resource type that is smart enough to know what the requirements are to actually consider that resource loaded or ready to load. So all of that's internal. We've already discussed that in previous streams. So this bit is already in place, right? So at this point, what happens is the resource system says, okay, we finally have a resource that is ready, right? So this pointer then is passed on to a system, which I think technically my arrows are wrong, right? This technically should go... Oh, Excalidraw is doing the weird thing. I think I'm going to have to refresh this page real quick. It is not allowing me to... There we go. Okay. I don't know why it's... This program does this sometimes. I don't know if it just doesn't like Firefox or something. I just drew all of this up earlier and it was fine. Okay, it's freaking out for some reason. Maybe I shouldn't use this app anymore. All right, well, essentially what's going to happen is I can't edit this for now for some reason. Essentially what happens is the K-resource system returns a pointer to the resource, which is more than likely not loaded yet, since that pointer is returned right away. However, that pointer will still be valid when the resource actually is loaded. So there's a status within the resource. that says how far along that process that resource is in terms of loaded, not loaded, etc. So essentially what happens is that resource is then, that resource pointer then would be returned to the system that called it, right? And then the system that called it would return an instance, what we call an instance. And all an instance is it's a structure returned by the individual system. In this case, static mesh system, right? I don't know why this is like flipping between two versions of this, but okay. And so essentially the static mesh system will say, hey, I have a pointer to this thing. Let's create an instance of that. And the instance actually contains a pointer to that acquired resource. But then it also will provide individual properties that are individually editable at a instance level. So there may be properties that, maybe we request the same static mesh 5 times, but maybe we want a different tint on each one of them or something like that. An instance would allow us to do that, right? Where the tint would vary per instance, for example. And so we get that, in this case, the static mesh instance, and that is our resource instance, which is owned by the kactor component. So this ultimately is what we're after, right? So we sort of do this whole loop thing where we kind of go around this whole set of systems, right? To ultimately wind up back here, and now we have a resource instance, right? And then the last thing to keep in mind is resource instances are structure containing a pointer to at least one K resource and hold individually modifiable properties of a resource. I mentioned that. Note that resource instances can reference other resources and resource instances as well. So this is an important caveat to keep in mind. So a resource instance, like a static mesh, kind of has a cascade of other resources that it references. So when we think about a static mesh has multiple submeshes, right? Each one of those submeshes has a material assigned to it. So that means that each one of those has a material instance. Each one of those material instances then also have their own individually modifiable properties, but also feedback to a material resource. In addition to that, a material itself is actually linked to textures, which are also resources, right? So you can have multi-layers of these things that depend on each other, and the systems are all smart enough to know to reach out to the other systems to get what they need. So we've got a texture system that's already in place. We have a material system that's mostly in place. I think there was still some refactoring to finish up on that. And we're looking at building the static mesh system tonight, right? And then we're going to convert our existing systems over to return instances of things instead of the actual resource itself. And that'll allow us to manage the life cycle of those resources a little bit easier. All right. So I hope that makes sense. It's a lot of talking, but yeah, I hope that makes sense. Thank you, by the way, for the follow. I appreciate that. Chris Koyo over on the YouTube side. Hello. How are you doing tonight? Welcome. Okay, so short of Excalibur just completely freaking out on me, which I have no idea why it's doing this. That is basically, I'll see if I can get this saved off to an image or something. We may wind up having to switch programs because I've seen it do this every once in a while, and it just like, it does goofy stuff like that. So, all right. So, where we left off was we were kind of feeling out how we wanted to start talking about K resources for different types. And so I've done some work off screen since the last stream, and we'll kind of talk about some of that stuff a little bit. I also went through the roadmap, right, and specifically the 0.8.0 release, and I added a bunch of to-dos to sort of spec this out and kind of how we want to actually want to handle developing all this stuff, right? So I kind of put in here some loose requirements of all the stuff that we want to build. We'll go through that, but a lot of it kind of touches on what we just talked about, right? So some of this stuff is new. Basically everything that's green here, its line starts with green, is all new, right? So the stuff that has X's in it, I've already done. And then the stuff with, just blank boxes like this mean that they're not done. And then ones with the dash that don't have a sort of checkbox in them are just informational, right? So it kind of contains sort of our spec and our to-do list kind of in one. So we have just a few things here. We have a lot of stuff that's already done, and then some cleanup stuff to go over as well. So we're not going to go through this whole list tonight. Obviously, we're just going to kind of touch on the main points and discuss the high-level aspects of a lot of this stuff and go from there. Casual Vim enjoyer, how's it going over there? Welcome. And if you guys have any questions at any point, feel free to jump into chat and ask, right? I'm more than happy to answer them as we go. Okay, so one of the first things that we have in here, and we kind of loosely talked about this already, we want to remove the geometry system. The geometry system is basically just managing geometries, but since geometries are kind of getting offloaded to be handled by individual resources, we don't really need a system for that anymore. So the geometry system as it stands right now is actually going to wind up being removed. We also are going to rename geometry to K-geometry, just because we have a lot of places where we have a member that's geometry, and we can't call it geometry because it's the same as the type. We're sort of moving towards this K nomenclature, the K prefix on our types, right? So we're renaming geometry to K geometry. That structure rename is already done. It's just the fallout of that needs to be completed, right? But that's actually technically done. And then we have to move creation of default geometry to geometry utils. So we've got to figure out a way to do that without a system in place. So default geometry is basically like we have a default geometry that's a cube, and then we have, I think, a default 2D geometry that's basically a plane. And it's just, a size 1 by 1 or 1 by 1 by 1, depending on what you're talking about. And those are just there in case we have a situation where we tried to load some geometry from somewhere. We're expecting geometry. We need to load or render something. And we don't have something to load. We have a default to fall back on. So that is what that is for. More than likely, the way that that's going to work is that's just going to be stored statically somewhere, and we'll just retrieve it. So we do need to do that. And then there's this other bit here that that I've already done off camera about adding a geometry type. Now, if we take a look at our geometry type, right? It contained, at least until recently, it contained a generation, which is incremented every time it changes, a center, extents, right? Those are just points. And then, vertex count, I should say vertex and index count, element size, vertices, and vertex buffer offset, right? Same for indices. And so rather than having to specify the vertex element size all over the place, what we're going to do is we are going to define some geometry types. And then we can infer from the geometry type what those sizes are in code. And we can simply tie them to, a vertex 3D or something like that. And so the advantage to that is it just simplifies our code a little bit, makes it a little bit more explicit, removes a little bit of the error. So our geometry types are unknown, which is invalid, right? So we're basically going to change anything that looks at geometry to say, hey, if we have unknown here, we're going to throw an error because we should not be dealing with a geometry type that is unknown. If it doesn't fit one of these, we have something for that. So we have 2D static geometry, which is basically 2D geometry that doesn't change. So that would mean the vertex data, it'll be a vertex 2D, which essentially will have just 2D positional information and texture coords, and that's it. And then we have 2D dynamic, which will essentially be the same type of, it'll essentially be the same layout, but it's for geometry that changes often, potentially every frame, right? And so the usage of that may be different when we're talking buffers behind the scenes. So we want to be able to differentiate between those two. Then we have 3D static and 3D dynamic. Same concept, but in 3D. They'll use a vertex 3D as their size. And that contains a little bit more data, right? It contains 3D positional information, texture coordinates, tangents, and normal, right? And I think also color information is included in there. And I believe the 2D static and dynamic also includes color information for like tinting. So there's that, right? And so these both will use the same format of vertex data. But then we have 3D skinned, which takes a different type of vertex data. Now, we don't have this implemented yet, but we're going to need it, right? So I'm putting it in here as a forethought into we need to prepare for this at some point. And basically, this is a special type of dynamic 3D vertex data, but it also is going to have skinning information when it comes to like bones, like what bones it's skinned to, the weights and things like that. So it's going to contain some extra data per vertex. We also have a height map terrain type, a 3D height map terrain type, and that's going to include the vertex or the material IDs and weights like what we have now. So we're just going to have a separate type for that. And then if it doesn't fit any of these, and we're not going to add one, we can also have user-defined types, which is custom. And so the user-defined type is what will actually use the vertex element size and the index element size. And the reason that we do that is because we want to allow the user to specify something manually, but otherwise we ignore unless it's custom, right? And that's right there in the comment. So that's the way that that's going to act. And so the geometry type is there. That's what we've done as far as that goes. La Folie, how's it going? Good to see you. Welcome. Beborn, how's it going? Good to see you. Good evening. All right. So we've talked about geometry. Let's see. Smudge and La Folie with a 5-streak for both of you. Awesome. That double, yeah. All the notifications popped up at once too. That's awesome. Appreciate it, guys. Thanks for showing up. Much appreciated. Smudge, I hope you're doing well as well. Okay. So we're going to jump back into our actor component system discussion, right? So we've already talked about what our actor is, right? It's something that can exist or be spawned into the world. It's similar to what we know now as nodes. So we're basically going to rename anything that's nodes into actors. It is mostly going to act pretty much the same way, no pun intended. So there's that. And then the properties that it will contain is each actor will have an actor ID. So this is a uniquely generated identifier of an actor whenever we create it. And what we'll need this for is lookups. When we go to look up an actor component within one of its systems, we'll need that actor ID because you could potentially have components name the same thing but with different actor IDs, right? So the uniqueness there is per component per component name and per component actor ID. So we have every actor has a unique ID. It also has a K-name, right, just for debugging purposes. And then this is the bit I'm not 100% sure on, and I haven't completely gotten to the bottom of this yet, but at a minimum, I'm thinking it's going to hold a hierarchy handle, and this will be used with the hierarchy graph, so that we can use the hierarchy graph to retrieve hierarchy information and transform things like that. We also have an XForm handle. I'm not 100% sure this is really needed because we can actually retrieve that information from the hierarchy handle. But it might be useful for somebody that is not using a hierarchy. And so if they wanted to use the XForm system directly without using the hierarchy system, maybe this would be useful. So I might include it. And then it says here, we just have a note for actors not using the hierarchy. The hierarchy would need to be managed some other way. So if the user wanted to create their own hierarchy system, they could certainly do that. And then an actor can have any number of k-actor components attached to it. And then we have here a component system will be responsible for maintaining this relationship. So the system maintains a list of components to actor IDs. It's better for memory, but it might be tricky when we obtain a list, or if we try to obtain a list of all actor types associated with a given actor, because we'd have to iterate all those systems. But I don't see any reason we'd ever have to do that, right? We shouldn't be really working that way. And when we're dealing with a sort of data-oriented system like this, we really should leave that up to the individual systems. We shouldn't be, iterating through, individual interfaces or anything like that. So that is sort of a caveat to the design, but I don't think that that's going to cause us any issues because of the way that we're writing things. Who knows? We may discover something down the road. That remains to be seen. All right, we've already talked about actor components, the actor component system, and then here I started breaking down the individual types. Let me see. Let me catch up with this chat here. Rain Zetself rather, sorry. First time chatter, welcome, by the way. Just got my first triangle in C Vulkan. I was using the official Vulkan tutorials, quite interesting. Initiating every piece of Vulkan for Vulkan to work and learning how it works. Yeah, it's a long process, isn't it? Still didn't understand some parts like the swap chains, queues, etc. So I hope they get that a bit later. Yeah, I mean, so swap chains are really something that you basically like set it up and you don't really ever have to touch it again once you get it right. So all a swap chain is it just maintains what's being presented to the surface at any one given time, right? And literally just swapping out images, hence the term swap chain. That's all it really does at the end of the day. And then queues just execute command buffers, right? So you load up a whole bunch of commands into a command buffer. You queue them up, so to speak, right? You load a command buffer with a whole bunch of commands, and then you send that off to a queue for execution. And that queue is what executes all of those commands. But yeah, you'll get all of that once you sort of get into it a little bit deeper. But I'm glad you're making progress on that. It's definitely super satisfying once you get that first triangle out, for sure. Ruche, thank you for the ghost high there. Appreciate it. Diamond, how's it going? Good to see you. Let's see. So is the queue the key to threaded stuff? That's a bit open-ended, but I think the way that I'm going to answer that is, and we have ads coming here in a second. So a queue essentially executes the command buffer, right? Now that command buffer could be, I mean, technically speaking, a queue can it doesn't necessarily execute everything in the order that you submitted it. There are situations where it can optimize that and do things at the sort of the same time, especially when it comes to render passes, and it can optimize all of that stuff. So it's not necessarily what you might think of when you think of a queue, but if you're talking about multi-threading, there is some of that happens behind the scenes, but also you can have queues on different CPU threads that get, that where you can sort of queue that stuff up on a different thread and submit to a command buffer and submit all that stuff on a different thread. So you can have different queues that do that. We haven't done that yet here, but we're going to at some point. It's kind of hard to explain in a 2-minute answer, to be honest. I wouldn't say it's the key, but it's a part of threaded stuff when it comes to a renderer. Did my SIMD math library in Zig. Took me 5 hours in Zig and 4 days in C. I can believe that. Definitely learned a lot about how the SIMD registers work when I implemented the C version. So I could look at the disassembly of the Zig version to make sure it did the right thing. Exactly. Which there's a strong benefit to that for sure. Zig does not have intrinsics. It has inbuilt vector types. Interesting. Okay. Let's see. Do you use any linear algebra library, or you made all this stuff by yourself? I made it all by myself. Yeah. We have our own math library. We try not to use, because this is sort of an educational thing, we try not to do too much in terms of libraries. We have ads. So for those of you who can still hear me, whenever ads come up on Twitch, which is once every 30 minutes for up to 90 seconds, I like to pause the stream so that nobody misses any content. So yeah, it's just we cover it up to 90 seconds because it varies on region and locale and platform technically. And so some people might get 90 seconds of ads, some people might get 15 seconds of ads, some people might not get any ads at all, but we try to take the lowest common denominator across the board for that. Your ad was 20, yeah, so it varies. So in Zig, you do at vector 4 f32, and for vec4, and if you do a plus b with that, it will infer the SIMD instruction. Yeah, that's pretty nice. So it's kind of almost like a fancy operator overload then. Odin does it too. Yeah, that's not too surprising. SIMD is one of those things that we have to tackle, but it's just not. It's not our performance bottleneck yet. So, in a way, but with type safety. Fair enough. We don't have such things in C. I mean, we do, but not really. All right. We are done with ads. So just to recap there, for those of you who couldn't hear me because of the ads, we like to pause the stream once every 30 minutes for up to 90 seconds, just because that's what Twitch serves its ads, right? So I say up to 90 seconds because depending on the viewer, your region and locale, you may get the full 90 seconds of ads, you may get 15 seconds, you may get none. So I try to account for the lowest common denominator and just pause for 90 seconds so that nobody misses anything across the board. All right. Some people get 0 ads because they are on YouTube. Yeah, I forgot to hit the ad button on YouTube, actually. I have to do it manually because I don't have a way to schedule it out, which is really annoying. Have you tried Odin yet? I have not. It's on my list of things to do, but frankly, I just don't have time at the moment, unfortunately. All right. Where were we? Okay, so we were talking about the K-actor component static mesh. So we have in here, this holds a pointer to a static mesh instance. I don't think that's going to be a pointer anymore. I think it's just going to be holds a copy. A copy of a K-res. In fact, this is not even going to be K-resource static mesh. It's just going to be static mesh instance. So that contains a pointer to the backing mesh resource, right? Which is an array of submeshes with geometries. And then it contains an array of K-resource material instances, which matches the submesh array, including duplicates for flexibility. So what that means is if we take a look at the new static mesh system H that I've been working on. Let's see, where is it? We have here a static mesh instance, right? And so this is ultimately what would get returned from the static mesh system whenever we request a static mesh. So we return a static mesh instance. It comes with its own instance ID. And then the mesh resource is just a constant pointer, right? So we don't want to be modifying that resource. We want to just have a constant pointer to it. And so this is the underlying resource that we get from the resource system, right? So it's just a pointer to that. And then we have a an array of material instances. So if we take a look at the k-resource static mesh, if we take a look at this, the k-resource static mesh has obviously the base information. It has a submesh count, and then it has a constant array of static mesh submeshes. And those are composed up here. So each of those has a geometry and a material name. Note that we store the name only here. And that's because the initial resource shouldn't have references to other resources. We only want the name of the resource. So that way, whenever we obtain an instance to it, we can reach out to the appropriate system and say, hey, give me the resource called this particular name, right? So in this case, what that winds up being is we have this pointer to this resource, right, which has the array of submeshes in it. So this array here is the same size as the subarray mesh within this guy, right? So they match up. So whenever we obtain that, essentially what we'll do is the system will say, okay, give me this resource, and then reach out to the material system and give me a material instance for each of these submeshes in this resource, right? And that's how we manage that. And then we'll return this, right? And then this structure is what the actual actor will use. And go from there. And that's more or less the way that we're going to set up most of our other systems as well. Let's see. Not a handle. You're talking about not a handle here. The reason I don't do a handle here is because resources don't necessarily work with handles. Here's the thing about it, right? So we actually have a couple things that I haven't mentioned here. So remember, an instance has individually modifiable properties. So one of those properties is going to be a vec for tint, right? And so we can actually specify when we return a static mesh instance, we can actually override the value of this tint, right? So we can say, even though we've got 5 instances of the same static mesh out there, right, which ultimately all point to the same static mesh resource, they all can adjust the tint individually amongst themselves. And that's obviously a contrived example, right? But that's the general idea. The same is going to be true of materials and things like that. And so the reason that we're not using handles in this case is because we do actually need the data out of this resource, right? We do actually need that. And then we do need the data out of the material instances as well. And that's one of the reasons we're using instances here and not handles. Because if we had handles, then we would have to essentially keep an array of all the instances internally, and then sort of look them up by ID, which I suppose we could also do. But I think it's a little easier to manage this way, especially when it comes to creating render data, which is something we haven't really talked about yet. Is it possible for the pointer to get invalidated? So if you were to say resource system, release this resource without releasing the mesh instance, then yes. But you shouldn't do that, right? What you should do is say static mesh system, release this instance, and let the system release the resource. Otherwise, it won't be invalidated, no. In that case, those pointers will never be invalidated. And that's because all of it is ultimately taken out of that massive initial pool of memory that we allocate up front. So we never have to worry about, even if we do hot reloading and stuff like that, we never have to worry about the address if there's changing. Do you modify an instance after it's created, even if they are all different? You can modify an instance, yes, but not the underlying resource. That's the distinction between the two. So when we talk about instance, let's say, for example, on this static mesh instance, we wanted to change the tint every frame, right? And maybe we just have a sine wave of it like going from white to black or something. We can adjust the tint on the instance, and when we go to render it, it's going to look at the tint on the instance because the mesh resource itself doesn't have that individually modifiable property. So it'll use what properties it needs out of the base resource, but then you can also combine that with properties that can be overridden per instance, if that makes sense. I hope that makes sense. Thank you for the follows, by the way. Siggy, hello. How's it going? Good to see you. Does that make sense? It does make sense. Okay, cool. All right. Yeah, I did a lot of thinking about this because I was like, I got thinking about, well, what if I just use the resources directly, that's going to be a problem, right? Pointers give me anxiety. Yeah, and I do get that. That's why we're switching to handles for a lot of things. But for this, it actually makes sense to have a pointer. Because this is ultimately owned by the resource system, which is why we have a pointer. So the resource system is ultimately aware of that. And so the underlying mesh resource in the resource system, the state of that, like the load state and all of that stuff, is actually generated, or not generated, is managed by the resource system itself and the specific handler for that type. So yeah, this is one of the few cases where we're safe to use a pointer, and that's one of the reasons why I also mark this const, because we don't want to be modifying this. We only want to be reading from it, essentially. Okay. So let's talk a little bit about render data, because that's going to be something that's going to come up a few different times. So render data is essentially the data that is needed to render a specific thing. So in this case, a static mesh. And so actually what we're looking at for an entire static mesh, this is the render data for an entire static mesh, right? Now, we also have a tint override here, right? Which is not to be confused with the tint here. Two different things. So what we have here is the static mesh render data. This is handed off to the renderer when we actually go to draw this particular type of thing. So we have an instance ID. An instance ID is taken from the instance itself, right? We have a submesh count and the submeshes, right? And each of the submesh, whoops, that should be a pointer. So the submesh count obviously is pulled from the instance. The submesh render data is a new array of data that is created based off of the submesh count. And so that render data is up here. We'll come back to that in a second. We also have an IBL probe index. So the scene can actually specify what IBL probe index we want to use within the scene. Usually that's going to be 0, at least early on. Smudge, thank you so much for gifting a tier 1 sub to LaFoley. Appreciate that. Gotta hop off to do chores. Good luck. Catch the VOD. Awesome. All right, Diamond, have a good one. Smudge, thank you very much for the support there. I really appreciate that, bud. And resubscribing at tier 1. I appreciate
Travis
that too.
168 happy.
Thank you, man. I appreciate that. Very much so. All right, so that's the probe index, and then we have a tint override. This tint override is pulled from the instance tint, right? Which I suppose we could call it tint override. Maybe I'll just call it tint. Right? And so you can see here how we have data that's pulled from both the resource as well as the instance itself. So if we take a look at the submesh render data, this just contains some very, very basic pieces of data. contains flags, which the only flag we have is whether the winding order should be inverted or not. That's for when we have meshes that are scaled negative in an axis. We need to reverse the winding order so that it actually renders correctly. And then we have vertex count and vertex buffer offset. Since this is a static mesh, we already know what the vertex size is, right? So all we really need is the vertex count and the vertex buffer offset. Same with index count and index buffer offset. And then we also pass along the material instance for that particular render data. So when we set up the render data, we're just passing along pieces of data and only the data that's needed to actually perform the render. So that we're not passing along all these pointers to things, right? We're extracting the data we need at the time that we're going to render it. And the other thing is because we're taking copies of all of this data, we're not using pointers. If that data is changing on the fly, we're not trying to change it while we're also trying to draw it, right? So we're essentially, whenever we're taking the render data, we're taking a snapshot of that thing as it is in time. So for example, if the tint is being modified once every update cycle, we're capturing that, right? All right. Okay, so I hope that makes sense. So that's the way that we're going to handle rendering, right? So the system is also going to be responsible for that. And so I started kind of putting together what our static mesh system might look like over here. And I didn't get this done, so we're actually going to work on this as our sort of project tonight. When people ask him how long he's been working on the engine, does he just silently measure his beard? Zach, that's hilarious. I've never heard it put that way before. Truth be told, though, this is only about, I want to say about a year worth of growth. And I've been working on this for technically about 3.5 calendar years, but, and there's a big but here, like Sir Mix-a-Lot size but, is it's less than full-time hours per week. So what I mean by that is like, if I was working on this full-time, we're probably talking about 6 to 8 months worth of work to build it. But since I can do like less than part-time hours per week, because that's all I have a full-time job and other responsibilities outside of this, it has taken me quite a bit longer. Plus, obviously, I'm streaming it, right? So there's conversations and other things that happen and things I need to maintain having to do with that. So, it's been 3.5 calendar years, yes, but we do actually have something. I came up with a way to actually be able to show this on occasion. Give me 1 second here. And I will see. All right, so let me see if I can make this work. I haven't tried this actually live yet, so let's see. I think if I switch to this, will it? Oh, it's not going to work. It's not going to capture it. Okay, well, I guess I can't yet. I was going to say, I have a copy of it running on my streaming machine, but unfortunately my desktop is not capturing for some reason. Not 100% sure why. Oh, there it is. Okay, so here is the engine itself, what it currently looks like, right? And so, you can see here that we've got UTF-8 text supported. We also have like a bitmap font down here at the bottom. And so we've got a basic PBR pipeline with cascading shadow maps. We have different debug views to sort of show you these different bits. So we have a lighting only view. And then we have a normals view, right? So you can see the normals. We have a cascade view, so you can see where the different cascades for the shadow map are. So the different color codes are just different zones of that. And then we also have a wireframe view available as well. And then we can also select objects in the scene and scale them or or move them or rotate them. Let me do. There we go. I'm not so good with the touchpad, right? But like we have the ability to do all of that stuff as well. And then I can actually save the scene as well, which I'm not going to do right now because I don't want to save those changes. But we have the ability to save and load the scene, right? So, and then of course we've got we recently added some reflective water, which looks halfway decent. I still need to tweak it a little bit. We've got LOD terrain. So if we go back to the wireframe view, you can actually see the terrain LODs changing as I move away from it. Especially if you look back here, you can really see it. Especially as I back off, right? So you can see all the way back there. Those are like the lowest level of detail, which is basically one quad, right? So yeah, that's essentially what the engine looks like for right now, right? Yeah, so I have Konnichiwa here written in Japanese, and then I have a Korean symbol right next to it just to kind of test that out as well. And yeah, we have, some basic UI elements in, and yeah, that's pretty much it. All right, so let's go back to this other view. All right. Dang, life always getting in the way at 11. Don't you know it? Do you also work on game engines at your work? Not currently, but I did for about 5 years. Yeah. I did that as my day job. But yeah, I got tired of working 70 hours a week, so I quit that. Started watching from the beginning recently. Really good to see it still going strong. Not a lot of these last. And that was part of my point, right? Because what I didn't want to do was I didn't want to put another tutorial series out there that shows you how to build a render and that's it. No systems surrounding it. None of that stuff, right? We're building an entire engine complete with all the systems that go with it. The only thing that we're probably not going to touch before we release our first game is like networking and probably physics, right? But we'll touch that on our second game. But we didn't want to have, a series where we just kind of build a half-assed renderer and then call it a day, right? This series has no end in sight, more or less. At some point, once we start like working on games, we'll probably move away from just straight-up engine dev. It'll kind of be a mix of the two. And then, I might end the official Kohi series there, but like Kohi is going to be continuously getting updates for, well, the foreseeable future, I'll put it that way. Annoying Haseo. Need depth plus overdraw. Yeah. Jesse Wayne, how's it going? Good to see you. First time chat, welcome. Looking very good, look very nice. I appreciate that. Yeah, so it needs some things. There's some issues around transparency sorting, which actually was working until I put in the water and I broke something in there. But since we're going to be redoing that anyways, I didn't bother fixing it. We'll fix it when we go ahead and fix the or when we refactor how all these things get drawn. Just do depth peeling. Yeah, so what we're gonna do is we're gonna try a couple of different techniques and probably support a few different ways of doing it in the engine because they all have their pros and cons, right? So the way we do it now is we split up our opaque objects and our transparent objects. We draw all of our opaque objects, and then we draw all of our transparent objects that are sorted back to front, right? And that works for the most part. There are instances where you have to like make your assets a certain way to sort of deal with that. But that works well for a forward renderer. Our deferred renderer, of course, is going to work the same way. It's just going to handle the opaque mesh, the opaque drawing a little bit different. And then eventually we'll do forward plus, but that's probably a ways off. So, yeah. we have plans there. It's just not in the near future, only because we have other more important things to do, at least at the moment. And at least for the first game, it's not really going to require any sort of super fancy transparency, right? Adding a lot of features to the engine. Do you have a game in mind for it, or is the goal to make an engine and not the game? So that was the other thing I specifically didn't want to do, is I did not want to make an engine and then not make games for it, right? Because how do you test an engine? How do you know an engine works if you don't create games with it, right? That doesn't really work. So yes, we do have a game in mind. We started drafting up a game document for it. All right. And this is woefully incomplete, right? But we spent a stream or maybe two talking about ideas, right? Ideas. And so what we're going to do is we're going to have a sort of endless runner style game. And I use that in quotes because it's not exactly that. Where the player is piloting some sort of vehicle, right? So it might be a hoverboard or a motorcycle or a spaceship or a submarine, something like that. When they travel along a road or path that has obstacles to avoid and enemies to engage in combat with, both melee and ranged. The player will have various types of vehicles, each having different abilities in various environments with their own challenges. Difficulty will increase as the game goes on. Later levels may also have vertical tracks, which the player can switch to when using a flying vehicle. So what that means is that, like, for example, one thing I'm thinking is the first level in the game, you're probably going to have a hoverboard as your only vehicle, right? And so you're going to be running along the ground with that thing and doing everything that there is in the ground level. But what you're not going to know initially when you play the game is that there are other tracks further up in the atmosphere that you can get to if you have a flying vehicle that contains its own rewards and challenges, right? And it's in the same level, so there's some replayability there, but you get to see that same level from a different perspective. So there's, vehicles are not tied to a level. You can use any vehicle for any level, assuming it's capable of traversing said level. So if you're on a water level, you can't use a motorcycle. The first level would literally be traversed, or initially be traversed with the hoverboard. If a player returns there upon getting the spaceship, okay, I just talked about that. Same goes for underwater. So there will also be like a boat that only goes along the surface of the water. Maybe you need a submarine to dive, right? So the tracks can go down as well. And so there's a bunch of other details in here about implementation, some stuff about input. We started talking about art style. We kind of came up with some basic, some vehicles, weapon ideas, that kind of thing. Some of the references we're using is Road Rash 3D, which is a very old game, but if you're familiar with it, you know where we're coming from. So this was basically a racing game where you had melee weapons and you could knock each other off motorcycles and stuff, it was really a lot of fun to play back in the day. This particular game was terribly implemented, but the idea was there. And then also there's this section in the original Final Fantasy VII where you're escaping from Midgar, and you're kind of going along this preset path, and you have vehicles that come up alongside you, and you have to melee combat them. So there's that concept, but then we've added other elements to it. We're thinking like for art style, something like a retro futuristic. This is a screen grab from The Fifth Element. This is another one, right, for an example, mixed with a sort of painterly / watercolor / drawing style. So these are just images I found on the internet. This is a screenshot of Borderlands, so I'm thinking like a style somewhere between this and this, and as far as actual graphics goes. And then we just have some other stuff in here. So we are working through a game design on that. We've done some of it here on stream. Once we get a little further along with the engine, we'll do a little bit more. But yeah. Road Rash was awesome. Okay, you know what I'm talking about then. Yeah. Motorcycle game in Final Fantasy VII was already really fun. I like where this is going now. Yeah, that's what. Yeah, we came up with the idea together on stream. It was a lot of fun. Is the demo you just showed correspond to the GitHub branch release version 0.8.0? Yes, that is on 0.8.0. The branch I'm on now is the feature K package, which it wound up ballooning way beyond just packages. But yeah, this is essentially going to all get merged into 8.0, but for right now, 8.0 does work if you pull it. Let's see. Final Fantasy VII was also really fun. Yeah, I played the crap out of it when I was younger, for sure. Oh, ads. And I do see there's some chats over here on the Twitch side that I'll catch up with after ads. So we've got about 50 seconds left on ads, and then we can continue. Almost done with ads. Okay, ads are dead. So, Skifferzy, first time chat there, welcome. You said cough Unity. What do you mean? La Folia, the only Final Fantasy VII. Fair enough. I mean, I played the remake, and the remake is fun. It's not the same game, though, for sure. I appreciate it for what it is. It'll never replace the original for me, but I appreciate it. I appreciate it for what it is. It's really cool to see. It's really cool to see those environments given a new perspective. You know, a new using new tech. I was thinking the other day about techniques for making something like Okami's art style. Yeah, that game was really cool back in the day. That was if I remember, that was a watercolor style game back on the PS2? Maybe PS3? PS2 or PS3? I don't remember. Really cool looking back in the day, though. It's not the same game, which is why I don't like it. Yeah, that's fair enough. Because you said, what's the point of making an engine if you're not making a game with it? Oh, right, yeah. Yeah, so that's exactly what Unity's doing, right? Like, they don't make games. Epic at least makes games using their engine. Unity, not so much. Which is why I think there's so many issues with it, to be honest. I think if you're making a game engine, you should also be making a game in-house with that engine. That's just my perspective, but yeah, that's a good point. I want the guys to stand in line while the bar goes up, and then I make a quick selection. Sergeant Pepper, how's it going? Good to see you. Sumi E, yep, that was it. Yeah, it was PS2, okay. It's been ported to everything. Yeah, fair enough. I wonder if it's on Steam. I should pick it up. Maybe instead of being a remake, it's reimagined. We need new terms for it. That's fair. Because they can't really... I mean, I get it is a remake, though. But it's not... What it isn't is it's not a high def, like an HD version, right? Because that would be a lie. Because, like, the story is actually different. But, yeah. It's not a remaster, exactly. Yep. It is truly a remake. But yeah. Like I said, I enjoy it for what it is. I appreciate it for what it is. A rebutcher. Yeah, I mean, the story leaves some things to be desired. But also it expands on some areas of the original story that weren't there, which I think is kind of a good thing. So it's pros and cons for sure. Okay. Where were we? Okay, so I think I basically talked through everything on this to-do list that we have to do. Obviously, the same kind of stuff applies for like the other component types. I just kind of specced out like what each one holds, right? So there's not anything crazy here. We're still working on resource system stuff for the individual handlers and whatnot. Okay, so I think that's going to do it for the to-do list for tonight. So let's go ahead and close that. And let's actually write some code. We're like almost halfway into the stream and haven't even written any code. All right, so what we're looking at here is the actual static mesh system, not to be confused with the static mesh K-actor system. Those are different systems, right? So the static mesh system actually deals with getting a static mesh. Now, why the difference, you might be wondering. The difference is, part of the philosophy of this engine is I don't want to force people into a certain way of doing things and using it. So if someone develops with this engine, they don't want to use my scene system, or they don't want to use my hierarchy system, or they don't want to use my actor system, they shouldn't have to, right? Separating this out allows somebody to literally use static meshes without using those systems. So if they want to go ahead and do that, they have that option. So that's why those things are separated out. I still expect remakes to be the same game. Anyway, still a good game, not complaining, just want proper open world remake of it. An open world remake would be awesome. But God, can you imagine? Can you imagine how many gigs would that take? That'd take terabytes, actually. And hot take, I would have settled for, or I would have been okay with them going a direction where maybe it wasn't quite as hyper realistic, or not hyper realistic, but high def, or highly detailed, like smaller textures, less detailed stuff, but still you kind of get the idea of it. Versus, I would have taken that to get open world. So like better than World of Warcraft graphics, right? But like say Final Fantasy 14 graphics, right? I would have taken Final Fantasy 14 graphics for a remake for Final Fantasy 7 if it was open world. I would have been okay with that trade-off. Okay, so get instance. So we need, the way that get instance is going to work is we're going to get, this is to get a new static mesh instance. So we're going to need a name for the instance itself. And then a name for the resource that's associated with that, right? So that's going to be the static mesh resource. So we need that name as well. What else do we need? We need a pointer to hold that instance. So we'll do a static mesh instance pointer out instance. And the reason we're doing a pointer here, right? We're doing an out pointer, is because we want to return a Boolean as to whether or not this was successful. Now, we could just return just this flat structure, right? But then we'd have to examine the structure to see, are its properties valid or not? It's much easier to just say, let's return a Boolean, and if this fails, it'll return false. And you check that before looking at whatever this points to. And I think that's just an easier and safer way to go. Because then you don't have to have your user code be concerned with all that other stuff. So a get instance, yeah, that should be good. I think that's all we're going to need for now. So static mesh system, we have not filled out at all. Cool. All right, so for our system itself, we have an initialize and shutdown, which is just like all of our other systems. And then we have a get instance. We probably also need a way to release instances, right? So we'll do KAPI, we'll do void, because if we fail on releasing an instance, what can we really do about it? We'll do static mesh system release instance. And actually that makes me think that we should rename get instance to acquire instance. But let's do static mesh instance, right? We're also going to need the struct static mesh system state. Let's go ahead and rename this one. You know what? Let's do instance acquire. This is going to be. It kind of makes it line up with the way we named stuff in the rest of our code base. Instance release. Right, so we follow the acquire release pattern that we have everywhere else. Okay. So we have acquire and release. Okay, the other thing that we need to do is we need to generate this mesh render data. So again, we're going to do KAPI, and we're going to have a B8 on that. Static mesh system render data generate. That's kind of long, but I don't want to just call it render because that's not what it's doing. It's just generating render data to pass over to the renderer. So we have struct static mesh system state. And then I guess we just pass along the instance, right? So we'll pass along, let's do a const pointer to that. Static mesh instance, and then static mesh render data. And we'll call this out render data. Right? It's a little long, but it's not going to be all that bad when we call it. Okay, so we have initialize, shutdown, acquire, release, generate. Do we need anything else? I don't think we require an update loop for anything. Nope. That should be about it. Right? And what we'll do is obviously this will return false if we're not able to generate that render data for some reason. Now, that doesn't always indicate a critical failure. So one place where we could fail to generate render data for a particular mesh is if that mesh is not loaded. If the backing resource is not loaded, then we're not going to want to create render data for that. Now, we could, if we wanted to, we theoretically could use default geometry for that, but I don't think that's strictly necessary. I think we could just not render it, right? So it's not necessarily a failure to say that this returns false. It's more, are we able to generate usable data, right? And if not, that's okay, we just skip it. Okay, so let's take all of this stuff, go over to the C file. We'll first include, whoops, try that again. static mesh system H. And we're just going to paste these in here real fast. Let's see. Okay. So, this first one is for the initialization of the system. So, first off, if we don't have memory requirement, there's absolutely nothing we can do. So we fail. If we pass in memory requirement but no state, that's okay. That means that we're just trying to figure out how much space we actually need. Now, speaking of this state, we don't have this type def yet. So let's do a type def struct static mesh system state, static mesh system state, and let's see, what kind of stuff do we need to even store in here? I don't know that we need to store anything for right now. So I'm just going to plug in for right now U32 dummy. So we got to have something in there, right? And then we're going to do dereference memory requirement. And we're going to say equals size of static mesh system state. That way, whatever we change it to, because I'm sure we're going to wind up adding something here. I just can't think of it now. We'll just automatically get that thing. And then we'll say if not state, return true. So the pattern here is, like our other systems, we call this twice. We call it once, passing a pointer to hold the memory requirement, and then 0 here. And then we call it a second time with allocated memory passed here. And that's when we proceed beyond this point. So if we have state, then we can do things like set state dummy equals 69 or whatever. Who cares? And we can do any setup we need there. Now, obviously, this is not needed because we don't have anything in there yet, but eventually we probably will. So at least by scaffolding all of this now, it'll make it very easy to change this system internally later on. So for now, we're just going to do that and return true. Right? Shutdown is just going to be a quick check to see if state, and then we're going to say to do shutdown. Now, more than likely, what we're going to want to do is, well, I suppose if we're shutting down the static mesh system, you would think that we would want to release our geometries, right? Or release all of our instances from the vertex and index buffers. But that's not necessarily what we need to do. Because when we shut down, it doesn't matter if that data is released because it's within a buffer, right? A buffer is just a huge block of memory. It doesn't matter. All that matters is that we destroy the buffer. So technically speaking, when we shut this down, we don't have to worry about that. Seeing you ran into an issue with 0.8 on Windows. Yeah, send me the console log. Just ping me on Discord and I can take a look at it. I haven't tried it on Discord. I know it runs on Linux and Mac OS. I haven't tried it on Windows in a bit. So maybe I broke something there. Did you clean and rebuild when you did that? Okay. So for instance reacquire, this is what is going to this is going to be a bulk of the work in terms of actually like loading stuff. So first off, if we don't have state, let's see. if we don't have state, or resource name is equal to invalid kname, right? Meaning it's a rubbish name. Or we don't have out instance. We're going to fail that, right? Because we need all of those things. If we don't have a name for it, that's not critical, right? We could just provide an invalid kname, and it's just not named. Not the end of the world, right? But the other things we absolutely do need. Let's see. The next thing that we're going to have to do is k-resource system. Oh, you know what? I'm going to need to include that. So include k-resources, or no, is it k-resource system? There it is. K-resource system. Right, and we need to request. Right, so we're going to need to do engine systems. Engine. You know what? We don't have engine either. So we're going to need to include. Was it core? Engine. Engine systems get. And then we're going to want the k-resource system. K-resource state, rather. We are going to pass along the resource name. And then the request info, which I don't actually know if we have specific request info for the static mesh type yet, because I don't know if we have a handler in place. So we might actually be stuck here until we do that. But what I'm going to do, static mesh. Yeah, I don't think we have that. So let me see if I can k-resource request info. And we're going to call this just request. Let's see if I can go with a generic one. So request type equals k-resource request. Let's see, wait a minute. I think it might just be k-resource type. Static mesh. Do we not have? Yeah, we do. Let me just make sure that that was the correct type for that. Yes, k-resource type. Okay. Request. Okay, so assets, right? So we're going to need to create an assets array. So we're going to need to do what was this? Array k-resource asset info. So we're going to create a new array with a length of 1. And we're going to say request assets sub 0. Oh, it should be data. Type equals k asset type static mesh. There it is. Request assets data sub 0 asset name is actually going to wind up being technically I think it's going to wind up being the same as the resource name. Request, oops. Sub-0 package name. I'm going to do invalid kname because I'm going to have to think about that, right? So let me finish up filling out this request, and then I'll explain why I kind of got stuck on that for a second. So we have listener instance. I don't think we're going to need that. Request user callback. I don't think we're going to need that either, right? Because we could just kind of check it. And then we pass to this the address of request. All right, and then this returns a k-resource pointer. So we're going to have k-resource static mesh pointer mesh resource is equal to this. Okay. We're going to need to cast that. Okay. So that's how we do a request to the resource system, right? So essentially what this does is it says, okay, here's our request. We're requesting a resource type of static mesh. Within that request, we have one asset, which is a static mesh asset. The name of that asset is going to match up with the resource name in this case. And then the package name, we're just going to say load it from any package. Now, we may want to optionally include like a package name here. We have resource name, right? But like package name may or may not be needed. Essentially what passing invalid name here does is just says scan all packages for this and return me the first one that you find with that name. And then a listener instance is just sort of contextual data that gets passed along, and then user callback would be a callback function of when the resource is loaded. I don't think we're going to need either of those things. I think we'll be fine without them, so I'm just going to not set those in this case. And then we reach out to the resource system to make the request. That's going to return to us a pointer to that particular K resource. And it'll return it to us even though it is not necessarily loaded yet, and that's okay. But we do need a pointer to that thing immediately. So the resource system actually owns that resource, so we don't have to worry about that pointer becoming invalid. All right. So the next thing that we need to do is we need to actually say out instance, and we need to do mesh resource equals mesh resource. I could have done this all in one line, but this helps debuggability a little bit. So we need out instance instance ID. And what we're going to do is k random u64, which is a new thing that I added. It's not really worth going into. We just use our Marsen twister RNG internally for that. Let's see. We're about to have ads here shortly, so I'll kind of try to blaze through this really fast. Out instance tint, right? So tint, we're going to default to vector for 1, which is basically going to be white. White, right? And then if the user wants to override that, fine. If they don't, fine. And then out instance, the last thing is material instances equals k allocate size of k resource material instance, right, times out instance mesh resource submesh count. The memory tag for that is going to be resource. Okay, so we create a material instances array. And then what we're going to do is we're going to loop through that and request material instances, right? Let's see. Why is data an array LODs? You can request multiple things. Yeah. So if we have, like if we're loading a cube map that's based off of 6 different textures, which we can do, then we would put 6 here, and we would have textures, and we would just request multiple assets. Yeah. So it's just this sort of structure that we can fill out with exactly what we need, resource-wise, and what we can also pass down to the asset system in terms of what needs to be loaded. Yeah. All right, we have ads. The other day I saw a game with scenes that are entirely made of a cube map. What? Like, the background of the scene was a cube map, or do you have a link to that by chance? It was one of those old point-and-click horror games. Oh, I could see something super old being that way. So it was kind of like Street View. I think I know what you mean. Yeah, I gotcha. Weird nowadays. I'm sure back in the day it was like, oh, this is awesome, but now it's just weird, right? Pretty impressive at the time, yeah. All right, ads are just about done, and ads are done. All right. So we go ahead and we fill out our instance, right? Let's not forget also down here to return true, right? Now we need to request material instances. So what we need to do is for u32, I equals 0. Hit the wrong button. I is less than mount instance mesh resource submesh count plus I. All right. And then we can do out instance mesh resource submeshes sub I. And what we're gonna do is we're gonna take a pointer to that just for convenience, right? So it's a const static mesh submesh, right? So we're gonna say const static mesh submesh pointer, right? And we're going to say sub mesh is equal to the address of that guy, right? And now we can look at submesh. And we have geometry and material name, right? So obviously we need material name. And material name is going to be used to request the material instance. So what we'll do is we'll do material system. I guess we don't have that, so let's go up here. Don't we have? Huh, okay. Include material system. All right, so material system acquire. So this is going to be, you know what, let me do this so we don't have to keep calling engine systems get. This is const engine system states pointer, right? So we'll say engine system states we'll say systems, engine systems get, right? And then we can just say systems. Now we can say systems material system. The name is going to be submesh material name. And the out resource is going to be the address of submesh. Wait a minute, not submesh. I guess we'll just do out instance material instances sub I. Right? And then I believe this returns a Boolean. It was found, otherwise false. Okay, so does this also give me the default material? I don't remember. Default material is provided. Okay, so it does give us the default material. So what I'm going to do is, in this case, if this fails, I'm just going to issue a warning and say failed to load material. We'll spit out the name of it for static mesh submesh, and we'll spit out the name of it as well. Actually, we'll say both, actually. Let's do it this way, actually. Static mesh this, submesh, name again, right? So the first one we'll put in there is going to be the material name, which we need to do kname string get. That's going to be the submesh material name. Then kname string get. We're going to get the string representation of the static mesh name, which is going to just be, we'll say resource name. And then finally the submesh name, which would be kname string get again. And this is going to be submesh. Did we not save off that? I thought we did. Do we have it in geometry? No, we have it in geometry. Not ideal, but it'll work. Okay. So we'll warn about that. I guess there's not really much else to do there, though. So that should be fine. Okay, so that's going to acquire the material instances, which will in turn make sure the textures are loaded. So that should have a knock-on effect. So we request all of that. The next bit that we'll have to do is we'll actually need to upload the geometry for each one of these submeshes. So actually, let's do this. Request material instance, right? And we'll do process sub meshes here, right? So we request the material instance, and then let's see, submesh. So if you look at the geometry, right, we have all of the stuff that we need to actually upload this, right? There is a slight problem with this, though. Something I didn't take into account. So all of this can be done. These items here can be done right away. Wait, no. These items can be done right away. From here down, can only happen once this is actually loaded. Which means we do in fact need our listener instance in our user callback. Because we won't know whether or not the resource is loaded. Like we won't have access to this information until the resource is loaded, right? So resource loading is asynchronous, or should be thought of as asynchronous. Right now it's technically not, but it will be once we jobify it. So I don't want to have to come back and refactor this code to make that work. So everything from here down will need to be moved into that callback. The callback I'll need to know. Let's see, what context will the callback need? It's going to need all of this, basically, up here. And that'll be enough. Okay. So the first thing that we have to do is we actually have to create a listener instance to hold all of this out in the ether, right? And that'll just sort of be passed along in the resource and in the request until that request is fulfilled, and then it's up to the caller to actually nuke it. So what we're going to do is right here, we're going to type def in the C file because I want to keep this private, right? We're going to do a new struct, and we're going to do static mesh resource request listener, right? Static mesh resource request listener, right? And this is basically going to contain all of this stuff as properties. So we're going to have the system state, the name, the resource name, and a pointer to, should we call it out instance? I guess that's fine. Mr. Friend, thank you for the follow. I appreciate that. Welcome. Okay, so we're going to have, yeah, this is what our listener is going to look like, right? And so what we're going to do is our listener instance is going to be, let's go ahead and just set that up right here. So we're going to do static mesh resource request listener. This is going to be a pointer, right? Because it's going to be dynamically allocated memory. Why? Because we need this to actually survive beyond when we actually make this resource request, right? So the size is going to be size of static mesh resource request listener. Memory tag is just going to be, we'll do resource again. Okay. So we'll allocate that. We'll say listener name equals name, listener out instance equals out instance, listener resource name equals resource name, and listener state equals state. All right. So we have all that, and now we can say listener instance equals listener, and that's a void pointer as far as this is concerned, right? So basically what happens is this listener instance just gets passed along through all the stages of that, and then when we make our callback, which we're about to write, we'll go ahead and receive that listener as part of that callback. So the callback, let's actually go to definition on that, because I could just copy this function pointer definition. So we'll come here, right below our type def, and we'll plop this in there. And instead, we're going to make this a static function, because we need it private, right? And we're going to say Static mesh on resource loaded. Right? And then we'll do static mesh resource request. Whoops. Static mesh resource request listener. Typed listener. Right? We'll just cast that and then pull out the properties from there. So we assign the user callback here. So we'll say static mesh on resource loaded. Oops. There we go. So now that we have our listener and callback set up, what we're going to do is we're going to take this, all this, remove it from here, and put it up here. Right? So these are the bits that we can do right away, and then anything that requires the assets / resource to be actually loaded and processed will be done in the callback. So let's see, we have out instance, so this needs to be typed listener, out instance. Same thing is going to be here. Same thing is going to be here. That's actually getting kind of long. I might have to do something about that. Okay, so material system, wasn't it? Let's just state. Oh, wait a minute. That isn't right, is it? We need the... No, you know what I'm going to do? I'm just going to do this. Submesh material name, out instance. This is going to be typed listener. Oops, let's be here, I guess. Type listener. Okay. It's kind of long, I guess, but I can't leave it. I can't bring myself to leave it. Let's see, we have mesh resource. Some of these don't matter as much. Like this warning doesn't really matter as much. This one we can just split this way and call it a day. Yeah, that's good enough. All right. So we request the material instance, and then we need to upload geometry data. Now, there was a something set up in the renderer. To actually upload geometry, right? Do I not have... I guess I don't have it anymore. I thought I did. Wonder if it doesn't show here because it's deprecated. It's only showing me some of these things. That's really weird. Let's go to... Yeah, see, like we have these deprecated geometry functions right here, which we're going to not use because we are going to eventually be removing those in favor of what they actually do into the head. So the renderer geometry destroy and the renderer geometry create / upload are what we essentially need to mimic. Oh, which these are all broken because of the rename. That's awesome. Maybe now is the time to remove that, although I feel like I'm going to break a whole lot of stuff if I do that. All this really needs is just to be called K geometry, and that fixes like 90% of it, but then there's still stuff like material that we have to fix. Because geometries used to have materials, and now they don't. It's up to the static mesh to have that. So it literally looks like this is just taking a copy of the index data, taking a copy of the vertex data from whatever we pass here, and setting it. And yeah, this is why this is deprecated, because this is rubbish, right? We've got much better ways of doing it. So what I really need to look at, the create doesn't matter, because this would have already kind of happened by our loading of the resource. So this is really what we need to look at in here. Again, let me just kind of fix some of the issues by doing that. So this is, let's just take all of this, right? And we'll pluck out whatever we don't need. Right. So this is uploading the geometry data. Plop that in here. Right. Obviously G doesn't exist, right? So this is going to be, this doesn't apply actually. Render system states. This needs to have a struct tag. Let's see. Okay, so we have re-upload handling here as well. Because a re-upload means that we have to free the old data before we upload the new. I'm going to go ahead and leave this in here, just in case, like, we might support hot reloading through this. So if I leave the ability to reload in here, that's probably going to be a good thing. Let's go ahead and take a convenience pointer to the geometry. So we're going to say kgeometry pointer g equals submesh geometry, and we want the address of that. Oh, I suppose we need const, right? Okay, so that does a lot for us. Okay. Render buffer allocates. So we need to allocate load range, and then we're done. But you'll notice here that we had geometry vertex buffer and geometry vertex buffer, geometry index buffer. Like, we don't have those things because we don't have the internal state pointer. So what we need to do is we need to grab pointers to those things. So we need to say render buffer, and we'll say geometry vertex buffer is equal to renderer, render buffer get, and a type. So render buffer type vertex. Right? We do that, and that'll give us that pointer to that, right? So we have that. Thank you for the follow, by the way. And then we have, we get a pointer to our index buffer, right? And now all we have to do is we can get rid of this this state pointer and the address of stuff, and we can just use that. So I'll just do, let's see, delete 3 words. Okay. Let's clear these highlights, get rid of those things. All right, so the vertex size we already have figured out. And then we have vertex buffer offset. Passing const to U64. Is that const? Oh, because the geometry is const. I didn't think about that. Because if this is not const, then that fixes that problem. Okay, so this... Wait, why was it bleating about... That's not... Oh, because the submesh is const. That's annoying. All right, let's just do... Let's make those non-const for now. Can't have them be const in this scenario, anyway. Probably the way this should work is we should get all the data that we need, then copy that stuff to the actual instance, and then make it const. But we're not doing that, so... let's see. Mod love from JA. I'm not sure what that means. Didn't think about that, the programmer's mantra. Yeah, we know that as dingus-oriented programming around these parts. Prime example of dingus-oriented programming. All right, let's see. So... Wait a minute, why do we... Do we even need this? It's the only place it's used in the file. We don't need that. Okay. Okay, so... Vulkan render geometry upload. Yeah, that's... Okay, that's not accurate. Static mesh. System. Failed to allocate from the vertex buffer. From the renderer's vertex buffer. All right. Okay, so before this was just kind of in the context of a single geometry, right? And so we could just return false and not have to worry about it. But in this case, we're going to have to keep track of like where we are in this sequence of events because we may actually have to undo some of these things that we've already done. So in this case, this is our first allocation, and we don't have to worry about that. So in this case, we can actually just continue, right? Skip. And we'll just say submesh geometry won't be uploaded. Skipped. All right, so we can do that. But for this, when we go to load the range, oh, why do we? I've got a to do here. Produces a queue weight and should be offloaded to another queue. This is our... That has to do with multi-threading. I should probably leave that to do there. We don't have multi-threading yet. Okay. Mr. Clear, thank you for the follow. We're about to have ads, by the way, so I like to pause for those so that nobody misses content when that comes up. That'll be a 90-second break, so if you need to hydrate or something, that's the time to do it. And Zaniac Games over there on the YouTube side, I do see your question, but we're about to hit an ad break, so I'm going to wait to answer it until on the other side of the ad break. There's the ads. LaFoy, you've been learning Sega Master System Dev this week for fun? That sounds awesome. Uses a Z80, so it's really easy to program. That sounds like a lot of fun. One of these days I want to do something like that. Just don't have the time with this project, unfortunately. Only so many hours in a day, unfortunately. And a third of those are taken by sleep. The only annoying thing is the GPU uses bit planes. Can you describe what you mean by that? Maybe I'm just not understanding what the term is. I might know what it is, but just don't know it by that. I assume because it reads stuff with a line per bit. I think I know what you mean. Alright, ads are dead. Okay, so, Zaniac, to answer your question, what is your projected time frame for the engine to be usable or beta? So, we're working on a release 0.8 right now. I would say it won't be usable until we at least market 1.0. I say usable with quotation marks, though, because technically speaking, 0.8 isn't necessarily released yet, right? It's the in-progress version. But you could pull version 0.7.1 and theoretically build a very simple game with that. We don't have physics, right? We don't have networking. And we probably won't have either of those two for quite some time. But technically, all the older systems that we're now replacing are put into place and they do work. So you technically could build a small game with that as it stands now, because we do have the ability to load up scenes, load static meshes. We don't have like skeletal animation is another thing that's missing, right? There's various things that are missing, but like you could hack around with stuff and make a simple game with it as it stands now. Maybe just adding game specific features on top of it. But it would be pretty, like, it'd be woefully simple, I think. But technically speaking, you could do it. Because we do have a sound system in place as well, which is another big thing that you can't really have a game without. But in terms of being viable for actually making a game, what the plan is with this engine is we are actually going to be building games for this engine as we build the engine. Now, obviously, there's a huge front-loaded process that has to happen to get most of these things in place to actually be able to build a game. That's where we're at now. But we've already started designing out the game that we're going to build. We've already got a game design document underway for that. And so here, hopefully, I'm hoping before the end of the year we can actually start on that. I've got to get this refactor done first. So I'm hoping to start the development of our first game by the end of the year. Once the development of that first game is complete, and we're at a point where we can actually ship that game, at that point, or maybe some point just before that, is probably when I'll cut version 1.0 of the engine. At that point, I would say it's usable. Things it probably, well, things it definitely won't have. It's not going to have a physics system because the first game we're making doesn't require it. It's not going to have networking because the first game we're doing doesn't require it. It's not going to have an editor, other than an in-game editor. It's not going to have like a full-blown like Unity or Unreal editor. That is in the plans, but it's not going to have that right away. Because just building that's going to take a long time as well. So it's not going to have that either, but you will be able to at that point construct a game. Yeah. I see. So 3D games into future plans, just 2D first, correct? No, our first game is going to be 3D. Yep, this is all 3D. We're not doing any 2D stuff. You could if you wanted to, but we're doing 3D. We're starting with a 3D game as our first game. Yep. Let's see, do I still have it up? Yeah, we're like, this is the design document that we have for the first game that we're creating. It's basically going to be like an infinite runner with vehicular combat, like melee combat. Think old Road Rash games or the Final Fantasy VII Escape from Midgar sequence, plus a few things, right? We're also going to have vertical planes, different vehicle types, things of that nature, different types of weapons, ranged melee combat, things of that nature, right? Vehicle upgrades, weapon upgrades, things of that nature. It's going to be in like a retro futuristic style, but visually kind of half between, a painterly style like this and like a Borderlands visual style is what we're thinking. And that's just a very quick, we've got a lot of work to do on this document still before we actually kick off the game, but we started already kind of getting together a list of features of things we're going to need to be in the engine to make this game. But yeah, that's pretty much it. So 3D all the way, just chunk by chunk based on the games. It's coming to make it more robust over time. Yep, yeah. And so the reason we're doing that is we don't want to get so far down the road in developing the engine and then try to make a game with it. And then determine we did something horribly wrong, right? We want to get the basics of the engine together, build a game, fix what we need to fix in the process of building that game, and then take notes of what we need to fix, maybe after the fact or whatever, and then add features for the next game, right? And just continuously enrich the engine as we go on and enhance it. Let's see. So all the pixels in a tile are 4-bit, so a pixel is a nibble, but instead of reading a nibble, it reads 4 individual bits from 4 bytes. 4 bytes describe 8 tiles. Think of it as column major structure instead of linear array. That does sound annoying. Wrote a basic tool to translate single channel into bit planes, but I'm making a pixel editor now since it'll be way easier. Yeah, that sounds super annoying. But yeah, once you have the tooling, then it won't matter. That's a great approach, as most studios do that in AAA space. Thanks for the info. Yeah, so that's it's a tried and true process, right? So that's what we're doing here, for sure. Because if you're building a game engine and you're not building games with it, what are you doing? Right? So we're definitely going to put it to the test as far as that's concerned. Okay. So at this point, we've allocated space in the render buffer, specifically the vertex buffer. Now, if we have a failure to actually load data to that range, we do need to bleat about it, but then we need to do render buffer, render buffer free, right? The buffer is going to be geometry vertex buffer. The size is going to be vertex size, and the offset is going to be geometry vertex buffer offset, right? Now, if this process fails, which it also can, the only thing that we can really do about it is throw an error, right? Because at this point, if that fails, it's not really recoverable. Failed to recover from write failure by freeing buffer range. Sure. And then once we've done that, instead of returning false, we can continue. All right. So that's pretty much how we're going to handle this all the way down, right? So if this is, if we have an index size, which the index size is, oh, there is something up here we have to fix. Let's see, vertex size, vertex element size by vertex count. Okay. So this is a known type of geometry that we're handling for static meshes. So we actually know the size of the vertex. So the vertex element size is going to be size of vertex 3D. Right? Same is going to be true for index element size. We know that we use U32s for this. So we're going to do that, right? Because remember we said for geometries of known types, we're going to use the internal sizing. We're not going to use that property, okay? So we have that. And then we come down here, and we essentially do, if we have index size, ooh, that's the only thing though. Oh, okay, I guess if we're not using index data, then the index count would be 0, and that would still come out to be 0. So I think we're good. Okay, so if we have an index size, meaning we have index data, then we check to see if it's a real upload. If it's not a re-upload, then we need to allocate some space. Otherwise, we upload the data. So we allocate the space. If that fails, we need to say static mesh system fail to allocate from renderer index buffer. And this should actually say good enough. Okay. So if that allocation fails, at this point, we have to undo this operation and this operation, right? So we'll need this, right? So we'll need to free vertex data, right? And at that point, actually, we actually don't have to undo the load, right? Because that's going to just mark the section as free, and then it can be overwritten with a different set of data. So all we really need to do is free it, on second thought, okay? All right. So let's say index write failure. While freeing vertex buffer range. And let's rename this one to fail to recover from vertex write failure by, or while freeing vertex buffer range. Be a little bit more explicit as to where the error happened, all right? So in this case, when we load the data, if that fails, we need to free the vertex data, but then we also need to free the index data in this case, right? So we need geometry, index buffer, index size, index buffer offset, right? And then this is also going to be index. Yeah, okay. Oh, this should be, this error message is wrong here. Index allocation failure, we'll say. Okay. Okay, so static mesh system failed to upload to the render index buffer. Okay, so now we've got all of that handled. if we hit any of these error scenarios, we don't want to fall down to here, right? We don't want to continue. So we're going to say here, continue. Oops. And if we get here into an error scenario, we're also going to continue, which I guess technically we don't need to do because there's no operations after this, but if we ever add them, we'd be kind of boning ourselves, right? So what this will also prevent is the geometry generation won't get incremented unless everything here is successful. Okay, so that all makes sense. So at this point, we will have requested our material instances and uploaded our geometry data. So this is where the power of using instances comes into play. Is because, oh wait a minute, you know what? There is one more thing I need to think about. There is one more thing I need to think about. When we acquire this technically is going to upload the same static mesh data multiple times. So we need to think about that too. Because we only want to upload this once, and we need to track that to say, well, we've uploaded this resource data already. So like when we make the request and we get that response back, if it's already loaded at that point, we don't need to necessarily do this. But if it hasn't been loaded to that point, then what? So I guess we could look at, well, we can't even look at the vertex offset, right? Because that could technically always be 0. Like 0 is a valid value. Because if it's the first thing to go into that buffer, it's going to be 0. I'm going to have to think about that one. So that's, I think I'm going to put a pin in that for tonight. If the resource was already previously loaded and thus uploaded to the GPU, then it doesn't need to be done again. Which actually makes me wonder, because we haven't written the resource handler for static meshes yet. So this kind of makes me wonder if we should handle this in the actual resource system instead of here. Because the resource system will know whether it's been loaded once or not. Okay, I'm gonna have to do some thinking about that. Not a huge deal. Just have to think about how I want to approach it. All right, let me see. Did you already build in support for localization? I can imagine that being tricky but fun set. We have not built it in yet, but we do have the ability to render UTF-8 text. And I've built localization systems before, so it's actually not going to be that difficult at all. So I'm not too worried about it. In fact, we probably will go ahead and localize the first game that we do. That's going to be something I want to do. Even if it's just minor, I'm going to try and keep text to like a dull roar in that game if I can. But there will be some text, and I will have it localized and translated. So I don't know how many languages yet, but yeah, we are going to be doing that for sure. Can you make distinct type defs in C? What do you mean by distinct type defs? I'm not sure I follow the question. All right. So I think this is where I'm going to leave off for tonight. Distinct as in incompatible with each other. Yes, you can do that. So like, if you do it in the translation unit, like I've done this here, right? This system state, I could technically go into another translation unit and type def the same thing. Or I could do it in a header file, right? And then they would, as long as I don't include the two separate files that have distinct, I guess as you call them, type defs, it'll be fine as long as they don't collide. But otherwise it'll say, like, hey, you've redeclared this, or something along those lines. Yeah, I forget exactly what it is. Or type incompatible, or I forget what the exact error message is, but yeah. Well, I mean, actually, I could just do this, right? I could just do redefinition of the state. Yeah, that's what it was. It's not what you meant? Yeah. Incompatible with each other. So, incompatible would be like, if you did like that or something. I assume that's what you mean. Otherwise, I'm not sure I follow. But yeah, anyway, let me undo that. Anyway, yeah, so that's gonna do it for tonight. Distinct would mean that they can't be used in each other's place. You know what? Ping me on Discord. I want to talk to you about that offline. I don't think I have the brain power to do it tonight, but yeah, I do want to talk to you about that because I am curious to know what you mean. Okay, so let me find somebody to raid. And before we do, I just want to, if you guys haven't already, I would ask that you toss me a follow either here on the Twitch side or over here on the YouTube side. Those things help me out a lot in growing the channel, and I'm trying to motivate more people to get into game engine development so that we have some competition out there. So yeah, I definitely appreciate all of those. Okay, so let me see if I can find something that's loosely related to what we're doing. Let's see. I don't know that I'm going to be able to find like C or C++ programming, but I'll try. Sometimes it gets a little bit weird at this time of night. Okay. Let's go ahead and we are going to raid Jetspow. So he's making a pretty sweet looking retro FPS. He's using Godot, but he's done some pretty cool custom stuff with loading BSPs and whatnot. And also he's got a pretty kick-ass feature that he put in there where you can basically throw books at things and interact with stuff, or really throw anything, but the original idea was throwing books at stuff. But yeah, you can basically interact with the environment. He's got a lot of physics things that he built in to to interact with the environment in unique ways. Like you can throw a book at an enemy to kill them and stuff like that. It's really cool. So definitely ask them about that. And yeah, I will catch you guys on the next stream. Thanks for joining me, and I'll see you guys next time. See ya.